Alhamdulillah, wassalatu wassalamu ala Rasulillah. Today, inshallah, we will study section 2.2. But we will start by revising quickly what we had in 2.1. I preferred, ya shabab, to delay the most of the exercises of section 2.1 to solve it together with 2.2 and 2.3. So we will finish 2.1, 2.2, 2.3, and we will practice at the end for all of these three sections. You can consider them as one section because mainly they are about functions and their graph and how to get information from graphs. We solved some exercises from 2.1 in the previous class. Today we will solve also some exercises from 2.2, and we will finish the remaining questions maybe not tomorrow, after tomorrow, inshallah. So let's remember, Shabab, what we had in 2.1. We defined the function, what we mean by a function. In fact, if you have two quantities, let's say x and y. So when y depends on x, we say that y is a function of x. Shortly, we write this sentence as y equals to f of x. This means that y is a function. Shortly, mathematically, we use this notation. So the function is a rule that assigns to each x exactly one y. So you can think about it simply like this. For each x, there is only one y. This is when we talk about y as a function of x. In general, for each input, there is only one output. And the domain, of course, the set here, the values, all the values of x, all the x values, all the possible x values are called the domain. And all the corresponding resulting y values, they are called the range. The y values are the range, the x values are the domain. Okay, what else we had? We will mention this maybe tomorrow more, the piecewise defined function. When you have a function that has different formulas over different parts of the domain. This is, of course, a function that is called piecewise defined function. What we also studied in the previous class, the net change. It is just the difference between the value of the function at the end and the beginning of the interval. For example, if you are talking about two numbers, and the difference quotient, it is just the difference between f of x plus h minus f of x over h. The main ideas are here, this one, the difference quotient and the domain. If you notice, most of the questions in all the exams are about these, but you may have questions about other issues, not only these issues. Also, in the previous class, we mentioned that we have 4 ways to represent the functions. We can use words like here, but usually we don't use words to represent functions, or formula or a rule, equation. Here we are like this. Usually we use this algebraic expression. And we can also use the table of values, numerical, and we can visualize also the function by drawing the graphs. Today we will focus on this part, these two, the graphs. This is what is 2.2 is about. It is about the graphs of functions. How to sketch the graphs of functions by using the idea that we used in chapter 1 in 1.2, plotting points. We have after that the vertical line test, or the VLT, in which we will know which graph is a function, which graph is not. Similarly, we can use it also to determine which equations represent functions. Finally, maybe tomorrow, we will see how to sketch the graph of piecewise defined functions. So let's start with defining the graph. Do you remember how we defined the graph in section 1.2? The graph of equation. Let me go back here, and I'm asking now, what is the graph of an equation? If you have equation, what will be the graph? Yes. Only two? In the linear case, you need 2 points to sketch the graph. But my question, Muhammad, is in general, what what do we mean by the graph of an equation? If you have equation, for example, here, let's simplify it for you. Y equal to x squared. What is the graph of such equation? Yes, in general.
I think in the graph that the corresponding values of x and y.
Okay, what is your definition?
All the possible values of x.
And y also.
You can substitute by x and then get the answer of y.
It is the set of all the points in the plane that satisfy the equation. So what you will do, you will find all the points in the plane that satisfy this equation, and you will join or connect these points, you will get the graph. So the graph of an equation, it is the set of all the points in the plane, in the coordinate plane, that satisfy the equation. What do we mean by satisfy the equation? It make it true. They make it the points that make the equation true. So similarly, we can define the graph of a function in the same way, because ya shabab, when we talk about a function, in fact, we have an equation. Look, y equals f of x. It is an equation. Now, if f is a function with domain A, then the graph of f is the set of ordered pairs. What is ordered pairs? Points in the coordinate plane. The ordered pairs x and f of x, so it is x and y, where x is in the domain plotted in the coordinate plane. In other words, the graph of f, the graph of the function f, it is the set of all the points x and y such that y equals f of x satisfies the equation. And of course, you can also think about it simply like what? If your graph or if your function is represented as an equation, then the graph of the function will be the graph of the equation. Look at this graph here. So at 1, this is f at 1. So this means that y here, y is 1. F y, it is f at 1. So this point, it is in fact 1 and f at 1. This point here, it is 2 and f of 2, the order pair 2 and f of 2. In general, x and f of x. If you look at the graph, you can see clearly that this is, of course, the height. What is the distance from here to here? What is the value of the function at 1? It is the height of the graph. If we are talking about a graph that it is above the x-axis. The height of the graph above 1, it is f at 1. The height of the graph at 2, it is f at 2, and so on. The easier function to start with is the linear functions. So this is called the linear function. And in fact, it is its graph is what? The graph of this line, y equals mx plus b. What is m? The slope. What is b? The y-intercept. Let's take an example. This is, of course, y equals to 2x plus 1. The slope here is what? And the y-intercept is 1. And you know, Shabab, when m is positive, the line will be increasing. It will be like this. And when m is negative, it will be decreasing. When m is 0, it will be a horizontal line. All of them are straight lines. You mean horizontal line. Okay, let's discuss the special case here. So the special case, when the slope is 0, what will happen? If m is 0, you will get what? Y equals to what? B, which is a horizontal line. So this means that we have a horizontal line. So we have here y equals to b. We mean f of x equals to b. So this means what? For each x, for any x, for every x, y is what? B. Always is b. So this is why they call it what? Constant function. It is always the same regardless what is x is. Let's take an example. It is a polynomial of degree 0. So let's take this example. When b is 3, this is y equals to 3, or the function, the constant function f of x equals to 3. Now, for any x, what is f at 0? What is f at 0? 3. What is f at negative 2? 3. Whatever f at square root of 2, whatever x is, of course, y is always 3. Constant function. The power function. What is the power function? when you have x to the power n, f of x equals x to the power n. Let's take it for simplicity, n here is a positive integer. But of course, it could be anything, but we will focus at this stage at positive integers. X to the equals 1 over n. This is a root function. Now, how to sketch the graph of a function that you don't know how it looks like? You will use plotting points. Let's assume, I think you are familiar with f of x equals to x squared, but if you don't, what you will do? You will make a table of values and then plot points. So let's make a table of values. You need to select x values from where? From the domain of the function. What is the domain of this function? All the real numbers. So here you can take x to be any number. So let's think about, let's go to the xy plane and we will do what? Now when x is 0, what will be x squared? 0. So we have the point 0 and 0. When x is 1 or negative 1, look, when x is 1, what you will have? 1. This is the point. When it is negative 1, it is also 1. When x is 2, 4. When x is negative 2, 4. Also, if you choose a half or negative half, it will be 4 here. If you choose more points and more 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 until you are sure about the graph, how it looks like. You may need 1 point, 2 points, 3 points, 10 points, 20 points, depends. If you are sure about the shape of the graph, then connect these points. Now, is this linear function? So don't use lines when you sketch the graph because it is not linear. It will be a curvy graph. So use curves like this, not lines, straight lines. So you can connect these these points by a curvy graph or a curvy curve. You can, yes, if you are sure. I said use as many as you want, but of course make it minimum, but you have to be sure.
Because they said that because we use like 3, it will be like an absolute value.
Here it is. This is the graph, how it looks like. I'm not talking about this specific function in general. Sometimes you need more than, for example, if it is a line, you need only 2 points. No need for more. X to the power 3. Now, by the way, if you want to sketch the graph of x squared, you will not use plotting points anymore. You know how it looks like. Khalas. When you have y equals to x squared, you will just write it as like this. That's it. Now x to the power 3. If you don't know how it looks like, use a table of values and plot points. So when x is 0, 0. When x is 1, 1. When x is 2, 8. It will go up there. Then when x is negative 1, negative 1. When x it is negative 2, negative 8. Now try to connect these also with a curvy curve. You will get the following. Now no need to use plotting points anymore, Shabab. Create your own table of basic graphs. Now, anytime when I ask you what is the graph of this equation or this function, you should be able to say that it looks like this. And this is why we say sketch the graph, not exactly. This is how it looks like.
So it's not necessary to.
No, this is y equal of course x to the power 3. The graph will be like this. Okay. Because we will use these functions later to sketch the graphs of other functions, a combination of functions. Square root of x. Do you know how to sketch the graph of square root of x? If you know how it looks like, no need to do anything. But if you don't know, you need to make a table of values. And when you create a table of values, you have to be careful because here you cannot choose any x. You should choose the non-negative values of x. X is greater than or equal 0. So choose any x greater than or equal 0. Here we are. These are some values. Now you will try to plot points. Now when x is 0, the square root of 0 is what? 0. When x is 1, square root of 1 is 1. When x is 2, square root of 2, square root of 3. Let's take 4. When you have 4, what it will be? 2 here. It will be here. When it is 9, let's take 9. Let's take 9 here, for example. Let's say that. So it will be 3. Now try to connect between these points again with a curvy curve like this. You will get the graph of x to the square root of x. No need to plot points anymore now. If I ask you what is the graph of square root of x, you should be able to say that it is starting here and it goes like this. This is the graph of x squared. Let's now summarize some functions and their graph. This is the constant function, the linear function with positive slope, and this is x to the power 2, x squared. This is x to the power 4. Look at it. The same color. Let me change the color. Look at this one and this one, Shabab. What you can conclude from this, that x to the power 2, x to the power 4, x to the power 6, x to the power 8, they have almost the same shape. But of course, it is more flat here near the 0, because when you have, for example, a half, when you raise it to the power 4, it will be more smaller. So this is why you have it like this. Similarly, this is the graph of the cubing function, x to the power 3, and this is x to the power 1. Also, it looks the same, but of course, the graph of x to the power 3 is more flat near the 0.
So from -1 to 1, that
More than, yes, because the values will be closer to 0. We will focus on this also in chapter 3 when we study polynomials. Square root of x, this is fourth root of x. Look, also they are similar, but of course, this is more, it will stay longer near 0, longer than square root of x. This is x to the power, the cubic root of x. And this is the fifth root of x. Do you notice that this is in some way it is coming from x cubed?
yes.
This is the graph of x to the power 3. This is what? The inverse. I am hearing some people that say inverse. You are preparing for 002. So in fact, the graph of the inverse will be the reflection of the graph of the original function or on the line y equals negative x, y equals x. Okay, the same can be said about the square root and x squared, by the way. Excellent. So the other types of functions, root functions, reciprocal functions. We will mention this also in chapter 3, but let's give an idea about them. Y equal 1 over x. X is not defined at what? Here, this will be undefined as at what? At 0. So look here. When x is 0, what happens? We have a vertical asymptote. X cannot be 0. Similarly, y cannot be 0. If you have 1 over x, it cannot be 0 because the denominator is not 0. Or in other words, if you solve it for y, also y cannot be 0. So also we don't have the x-axis here. It is a horizontal asymptote. So this is the reciprocal function, the graph of the reciprocal function. When you have 1 over x squared, it will be like that. We will focus on, this is the last section maybe in chapter 3.
What's the name of the line?
Horizontal asymptote. Yes. They will never ever intersect each other. They will stay neighbors forever. Okay, now the question, which graph represent functions? How can you know which graph is a function, which graph is not? The answer is use the vertical line test, the VLT. What is this test? Let me give you something that you see before. Y equal x squared. The graph is look like this, right? If you draw a horizontal line, a vertical line, it will intersect the graph only one time. So this is function. Now let me give you another graph. Let's take the one that is related. Y squared equals to x. Do you know how to sketch this equation? We mentioned this, by the way, I think in 1.2. It was one of the recitation questions. I don't remember exactly. But how to sketch the graph if you don't know how to sketch the graph? What you will do? Plot points. But here it is better to start with y and then find x. So when x is 0, when y is 0, what will be x? When y is 1, when y is negative 1, x will be 1. Similarly this. So now you will go to plot points. What you will get? 0 and 0, 1 and 1. When it is 1, it is 1. When it is negative 1, when you have x equals to 1, when x equals to 1, you have what? You have 1 and negative 1. So you have 2 points corresponding. Similarly, if you have here points here, at 2, when x is 4, let's say, when x is 4, you have 2 or negative 2. Look, so you have here points here, points here. Connect these points, you will get this graph. So let me draw it here. It will be something like this. In fact, when you replace x by y and by x, you are replacing the x-axis by the y-axis. So this is why the graph, this graph that was on the y-axis, it is now in the x-axis. Now, if you draw a horizontal, a vertical, why I'm talking about horizontal, we use there is a test, by the way, called horizontal line test for one-to-one functions. Now, if you draw any vertical line, it will intersect it more than. No need to draw. Just if you find one line is enough. Just to find one line that intersected more than once, then it is not a function. So we have the following test that says a curve in the coordinate plane is the graph of a function if and only if no vertical line intersects the curve more than once. What will happen if intersected more than once? You will have one x that has what? 2 y's, more than 1 y. We should have what? For each x, there is only 1 y. So this is why this test is how it works. It is a relation, a rule, whatever it is, but it is not a function. It is not a function. The function is a rule or a relationship, a formula that assign for each x only 1 y. By the way, we are talking about y as a function of x. Be careful. Now tell me which graph represents a function, which graph is not. The first one, A is not a function. It is not a graph of a function. What about B? Yes. Try to find any line. If you can find the line that is intersect the graph more than once, it is not. So this is a graph of function. Also C. The last one, it is very not. In fact, it intersects we have a vertical line that intersected more than once, more than twice, 3 times. Now, how can we know? Yes. No, this is a function, by the way. Y to the power 3 equals to x. It is a function. Take the cubic root of both sides. Y will be cubic root of x. This is the graph. The graph of x is like it. Okay. Good mistake. This is, of course, very important to bring this out during the class. Now, which equation represents a function? Can you know from the equation itself that it is a function or not? How?
Which has more than one value.
You can sketch the graph of the equation. This is one way, and use the vertical line test. But also you can use the equation itself. We will see that. Yes. How? No, like without graph, how can we do that without a graph? We know, ya Shabab, we can do it by using graph. Okay. Now, Abdulaziz, stand up, ya Shabab. You are stand up. Try go and wash your face, no problem, and come back. How to know from the equation that it is a function or not? Yes.
The exponent of y.
Again?
Exponent of y shouldn't be.
Solve it for y, you mean?
No, only the exponent.
The exponent? No, it is not about that. In general, I'm talking not about this, ya Shabab. In general, how to know from the equation that it is a function or not? Yes.
We solve for y, and if the y has one solution, then it's function. If it has more, like 2, that's function. Because all
Okay. Good. So we need to solve it for y and see what is for any x, for each x, there is only one y. If I can prove that, this is a function. How to disprove, how to show that it is not a function? Let me write here, Shabab, the definition of the function. For each, where to write it? Let me write it here. For each x, there is only one y, right? This is how to prove. How to disprove? To disprove, how to disprove? What is the converse of this statement? There is at least one x. If you can find one x with more than one y, or corresponding to with more than one y, then what? More than one y, then this is not what? This is disproof. You disprove, and here you need to use this to prove. This is proof. Again, this is, ya shabab, well known in the basics of mathematics. If you want to prove, you need to prove for all. If you want to disprove, bring one. Give me one counter example. If you have one counter example, then you disprove. Good. So now let's start. Of course, we will assume, ya shabab, usually that everything is fine. So we will start thinking about that it is a function. Now, this is what you should always do. I think, as Abdullah said, let's solve it for y at the beginning. So what we have here, x squared plus 2. Now, how to prove or disprove? If you are not sure, if you have any doubt about that it is not a function, try to think about some values of x that make that have corresponds to 2y values or more. You cannot find. Give me here any x that has more than one y. You cannot find. So you need here what? To prove. How to prove? You can prove it by two ways. One is to sketch the graph. I told you about that. It is not difficult. How to sketch the graph if you don't know how it looks like? Plot points. When x is 0, what you have? 2. When x is 1, 3. When x is negative 1, 3. So it will be like this, by the way. We will study this later in 2.6. It will be the same as the graph of x squared, but shifted up 2 units. Now, if you draw any vertical line, it will intersect it only once. But this is not what I want here. I want to show up here to show you how to do it from the equation itself. Now, for each x in the domain, of course, x here is in a real number. For each x, there is only one x squared. Is that right? When you have x, when you square it, are you going to have two values or one value?
One value.
One value. And also what? Only one what? And only one x squared plus 2. Is that right? Are you going to have two values if you add 2? No. So you have only one what? X squared plus 2, it is y. So this is a short proof just to show that how can you show it in general. The details are here, Shabab. And also the graph is here by both methods. Let's go to the next one. Function or not? Why?
Circle.
It is a circle, and the circle is not a function. Any graph, any line will intersect the graph of the circle twice. How to show it algebraically? Solve for y. Y squared equals to 4 minus x squared. Take the square root of both sides. What you will get? Absolute value of y equals to what? Positive or negative the square root of 4 minus x squared? If you wrote this, I will make it 0 for you. This is not true because absolute value cannot be negative. So this is what? True. Now y will be positive or negative. Usually this is why to avoid this confusion. So we have also here another question, by the way. If you have equation like this, it is not a function. Now here, you can find so many, infinitely many x values that corresponds to 2. For an just give me one. Take x equals 0, what you will get? positive or negative 2. So you at least you have one, but in fact here you have infinitely many points. Only a negative 2 and 2, they will have one y. Otherwise, which is 0. Otherwise, everything, but you need only one to disprove. This is the graph of the circle. How it can be a function? It cannot.
I'm sorry, Doctor, why don't we, from the beginning, remove the radical? That will be 2 minus x.
Sorry?
Just a view only.
Hello? What you are talking about? So you are saying that why we just write it like this?
It will be y equal
Uh-huh.
positive or negative 2 minus x.
What you are saying again? You are saying that this is equals to 2 minus x? Is that right? Be careful. This is so a common mistake, please. You cannot distribute. You are saying that the square root of 4 minus x squared is equals to the square root of 4 minus the square root of x squared. This is not true. You cannot distribute the radical over the product, over the sum and the difference. Please, ya shabab. Good to bring this mistake inside the class, not in the quiz or in the exams. Please. So now I think it is time to practice. Do we have time? We have time for that. Now start, ya shabab, select the equations. They might be one or more equations that define y as a function of x. Now just you need to say, it is a function, it is not. Y is a function of x, y is not a function of x. And why? Justify your answer. You have 8 equations here. Start, I will take the attendance. Do whatever, any justification. Okay, let's take them one by one. The first one. Is it a function or not? Muhammad, you are saying it is a function? I can easily show you that it is not a function. Take x to be 1.
Yeah, I saw this for y, then I took the square root.
Okay, so this is what you should do. You should try to solve it for y. Y squared equals to what? X squared, right?
Yes.
Then you will take the square root of both sides. Then what you will get? Y, the absolute value of y equals the absolute value of x. You remember this from 1.8? What does that mean?
Y equals negative x.
Positive or negative x. Or you can just stop here and start thinking. If you let me write this, of course. If you take, for example, this means for an instant, for example, if you take x equals to 1, what you will get? Absolute value of y equals to what? Absolute value of 1, which is what? So the absolute value of y equals to 1 means that y is what? Positive or negative 1. Okay? So it is not. Yes.
Why did you remove the absolute value from the x?
You can put x equals positive or negative y. They are equivalent.
No, I mean, I put y equals positive or negative absolute value of x.
Really? This is the mistake that I mentioned before, that it is a huge mistake. Y here equals to the absolute value of negative x. It's okay. It's okay. You are right. Because here y could be positive, could be negative. It's okay. It is okay. Now the absolute value of x, it's okay like this. You're right. I was thinking that you are doing the other way. Here, of course, y is the absolute, but this is positive always. So in fact, here, when you have, we mentioned this, ya shabab, in 1.8, when you have the absolute value of a equals the absolute value of b, this means what? Or negative b. So this is why it is clear to have it like this. Because you know, what is the absolute value of x? It will be positive or negative x or negative x. So at the end, it will be positive or negative x. Okay. So this is what it should be simpler at the end. Okay. So this is not a function because we are able to find one y or one x that has or corresponds to more than one y. One input with more than one output. What about this?
Not
How did you know that it is not a function? Solve for y. Move y to this side. So it will be what? X plus 5 equals to the absolute value of y. What you can do more? You can say that y is positive or negative x plus 5. Of course, if x plus 5 is positive. If x plus 5 is negative, this has no solution. It does not exist. It has no meaning. Now, or you no need to do this, by the way. You can here start think about a number. For example, take x equals 0. What you will get? 5 equals the absolute value of y, which means that y is positive or negative 5. So we need to disprove. To disprove, it is enough to have, of course, one value that does not satisfy. Yes? Yes, this is if you want to disprove, counter example. But if you don't want to prove, you need to prove for all. Y equals positive or negative 4? Why? It is a constant function.
Because it's gonna be two horizontal lines.
Aha, excellent. If you sketch the graph, this is the x-axis, the y-axis. If you sketch the graph, you will have the graph. This is y equals to 4. This is y equals to negative 4. Now, if you draw a vertical line, it is enough to have one. But in fact, any vertical line here will intersect it more than once. It is enough to have one. But also it is clear, Shabab. It says here, I'm two values, I'm two y's. For each x, there is always two y's. Yes.
So how can we draw the
We will see that. We did that, by the way, in 1.2, if you remember. Again, if you don't know how it looks like, what you should do? Make a table of what? Table of values. So you will make here x and here the absolute value of x. When x is 0, you will have 0. When it is 1, you will have 1. When it is negative 1, you will have 1. When it is 2, you will have 2. When it is negative 2, you will have 2. And it will be like this. This is the graph of y equal to the absolute value of x. We will have it maybe tomorrow as a piecewise defined function. It looks like V shape. So here, Shabab, for any x you have two values. Not only for one x. For each x you have two y's. For any input you have two outputs. So this is very not a function. What about this one? Function. How to prove it? Yes, one Abdulaziz صح. Now, yes, you can sketch the graph. And of course, it is not difficult. If you don't know how to sketch the graph, plot points, use a table of values. Or we will see that in section 2.6 together, inshallah. Start with this function, you know what is it, then shifted what? It will be the same, but shifted to the left, 4 units. We will talk about that later. So let's forget about the graph for this moment.
But it's the 4 inside the root.
Inside the root, yes. It will be shifted to the left. If it is out, it will be shifted up or down. Okay, we will talk about that later. Now, for each x, there is only one x to the power x plus 4, right? If you have x, if you add 4, are you going to have two values? No, it will be one value. And also there is only one what? Cubic root. If you have any number, if you take the cubic root, it will be one number. So there is only one what? One y. So it is clear. All the odd roots, of course, but you have what is inside it. Yes, you have to be careful. You have to be careful when you say that. And try to find any x if you are not sure. If you can find x, you put it there and you'll have two values. This is, of course, something that you may consider also. More than enough. More than, but we are talking, we are looking for something easier and simpler and will not take time. Of course, by using the vertical line test. What about this? You are right. Excellent. It is a circle. And it is enough justification. It is good time, by the way, to revise 1.2. So bring this to here. It will be plus y minus 3 all squared equals to 25. This is a circle. This is a circle centered. Let's revise. Centered at what? 5 and 3 with radius 5. It is clear that it is a circle, and because of that, it is not. If you don't want and you didn't realize that it is a circle, what you are supposed to do? Solve it for what? Or think about x, some x values. Think about x equals 0, for example. Or solve it for y. So it will be what if you want to solve it for y? Y minus 3 all squared equals to 25 minus x minus 5 all squared. Then take the square root of both sides. Will be positive or negative. The square root of 25 minus x minus 5. We did 2 steps in 1 step. And then add 3 for both sides. Clearly for of course, infinitely many x values, you will have 2 values for y because of this positive or negative. Unless this is 0 at 1 or 2 points only, but this is enough to have 1 x. If you are not sure, ya shabab, you can just take, for example, x equals to 0. Look here and take, for example, x equals to 0. This is another way to disprove. Okay, so you will have what? 25 equals to 25 minus x minus 3 minus y minus y minus 3 all to the power 2. This is a way to disprove, not to prove. This will be 0, y minus 3 is 0, x squared. Is that right? We are unlucky here because we obtain what?
One value.
We obtain 1 value. So this is not why it is not, of course, a proof. So if you find that it is 1y for 1x, it doesn't mean that it is for all of them. Bidalil, take another one. Take, for example, x to be 1. Take x equals 1. What you will get? If x is 1, what you will get? 60, right? And what you will get here? Negative 9. Unfortunately, also this is negative. We have here negative. It looks like we forget that negative there. It's okay. Now multiply both sides by what? It will be 9 y minus 3 all squared. Now take the square root. It will be positive or negative 3 equals to y minus 3, right? Of course, when you have a number that is showing, it is not a proof. You should prove it for each if you want to prove. But if you want to disprove, give me 1. We weren't unlucky when we choose x to be 0. So this is why you have to choose another number. This shows that you have 2 y values, because here y will be what? Y will be 3 plus or minus 3. So you will have y equals to 6 or y equals to what? Yeah. For 1 x value, you have 2 outputs, 2 y values. What about this equation? It is a function, right? Why you said it is a function? How to prove? If you said it is a function, prove it. It is a vertical line. So what is the problem if it is a vertical line? Now use the vertical line test, bring a vertical line test and draw it. How many intersection points? Infinitely many. So here indeed, what does this equation say? It says for any y, we have only 1 x. What is it? 5. So when x is 0, what is when y is 0, x is what? 5. When y is 1, x is 5, and so on. So here, this is a function, and we can generalize this. The equation of any vertical line does not represent a function. Does not represent y as a function of x. Okay? Excellent. What about the horizontal, shabab? It is a function. Not only that, it is a constant function. The constant function. What about this one? Not a function. Who said not? Give me a number. Give me 1 value for x that result 2 values for y. 5. Y minus the absolute value of 5 equals to 0. What you will get? What is the absolute value of 5? Try another one. Doesn't work. Minus 5. Y equals minus the absolute value of minus 5 equals to 0. It will be y minus, what is the absolute value of minus 5? Equals to 0. Y equals to what? 5. We have only one y. For any one input, you will have only one output. So it is what? But this is not a proof. If you want to prove, you need to prove for any x, not for 5 and negative 5 only. So how to do that? Solve it for what? And this is in fact the absolute value function. Now, if you are not sure about that, sketch the graph. If you don't know the graph, we mentioned this before, ya shabab. The graph of this function looks like this. We will repeat this tomorrow. We will consider it as a piecewise defined function. And if you draw any vertical line, it will intersect it only what? Once time. Give me one horizontal, one vertical line that intersected more than once. You cannot find. Or you can say simply that what? For each x, there is only what? There is only one absolute value. Give me the number that has two absolute values. And the absolute value is what? Y. Okay, that's it. The time is up, and see you tomorrow, inshallah. We are done. Oh, we have the last one. If you want to leave, Shabab, leave. The last one is the constant function. Constant function. So we end up with three functions that they are the three equations that represent y as a function of x, but for the others are not. Welcome.